Good morning, everyone, and welcome to the learning discussions about pseudocode. The objective of this learning session is to learn about pseudocodes, how to convert algorithms and flowcharts into pseudocodes, and how we can use pseudocodes to solve problems while thinking computationally. Like flowcharts, pseudocode is a way of planning out the design of a program, engaging in higher order thinking about what the program is doing without the extra cognitive load that comes with working with the details of a programming language syntax. It is also a way to express what an algorithm does that is readable to those without, say, not a whole lot of expertise with a particular programming language syntax. And that also means that it can be a stepping stone to learning how to program, right? So finally, pseudocode makes it easier to collaborate with colleagues, especially when you're working on, sort of these large application projects which might have smaller components, and different teams are working on that. Hi again. I'm Rashmi. I am a mom of two. I'm a director of digital learning and library at Arlington Public Schools. I also work with a nonprofit called STEAM Futures, and with the wonderful team at Leslie's STEAM team at Leslie University. Um, so, what is algorithm? Sort of, let's go back to the discussion of algorithm, flowchart, and pseudocode. Okay, so we've already seen that algorithms are a mathematical method of solving problems, both big and small. Through though computers run algorithms constantly, humans also use algorithmic thinking, algorithmic process to solve problems. It's a problem solving process to analyze the sequence of steps one needs to take in order to solve the problem that's in front of them or collaborate in solving that problem. And a flow chart, as we know, is a picture of separate steps in a process in a sequential order. You do use specific standard mathematical geometrical shapes, such as the diamond in here, which is used to represent the decision tree. So again, sort of let's refresh our memory. Programming is the manifestation of logic. The program is a set of instructions that defines the behavior of your application. And writing code is how you sort of implement it for the machine, right? So that's like this pen down count um, less than zero with a negative, so you are reducing it. Repeat until count equals 4. That is sort of the programming instructions in a format that is readable in English, and we'll talk a little bit more about pseudocode. So, what is pseudocode? Pseudocode is informal steps for an algorithm using structured English. There is no specific syntax for pseudocode, and it should be human readable. That is one of the prerequisites so that a programmer can translate it into program code. Pseudocode literally means fake code. It is an informal and contrived way of writing programs in which you represent the sequence of actions and instructions, which are aka algorithms, in a form that humans can easily understand. You see, computers and human beings are quite different. We know that. And therein sort of lies the challenge of communication, right? The language of a computer is rather precise. You are expected to communicate exactly what you want the computer to do, nothing less, nothing more, and to not deviate from the rules because computer listens to the programming language and will literally sequentially follow the steps that you have articulated for it. Even with the invention of higher level languages, which are human readable languages such as Python or JavaScript, it is still very difficult for average people like us, or even developers or programmers, to reason and program in those coding languages. So, pseudocode is a really great way of collaborating with people who might be using different types of programming languages, but the logic that they are communicating, it gives them like this common platform where they can talk about the logic. Another way to explain that pseudocode is sort of saying that it's a simplified representation of an algorithm that uses the English language to describe coding logic. It allows programmers to plan any type of programming language or algorithm structure using simple written commands and instructions. Pseudocode primarily uses plain text to describe various coding actions and their correct sequence in the program or in the algorithm. Although some types of pseudocodes also use mathematical symbols to reference or represent data sets, while programming languages like Java exist for computers to process, pseudocode exists for humans to read and understand and communicate the logic of the program. Because computers can't interpret pseudocode, programmers then need to translate this pseudocode into a programming language, higher level programming language, to produce a functional algorithm. Programmers can interpret each line of pseudocode into the technical specifications of their preferred coding language syntax. Simply put, pseudocode is used to formalize steps taken to solve a problem, in this case, an algorithm. So let's imagine we are back in the days and that we want to find the long lost friend of ours in a phone book. I don't know how many of you remember the phone book, but if we have to find a long lost friend of ours in the phone book, and the only thing we know is that their name starts with a J. Now, one solution would be to, of course, flip every page of the book from the start until we arrive at the J page. But that would be quite quite long and may not be as efficient. So, another solution could be to say flip the book in the middle of the book and then access if J is on the left side, assess basically. Is the J on the left side or is it on the right side? And then flip towards the appropriate side in the middle again and do this until we find the J page. And this would be rather more efficient and you would find J in the phone book. So that's your algorithm, right? And following is an example of how to formalize the pseudocode for the second algorithm. Right here, you can see. And we will also explain to you in this video how to take another sort of a flowchart or a problem statement, convert it into a flowchart, and then create a pseudocode for it. Here is one. Um, why use pseudocode, right? Because programming languages involve complex technical details, pseudocode is an easy way for people to understand the basics of how a program functions without having to learn complicated mathematical notations. Programmers often use pseudocode as a prototype before writing the actual technical code for a program, allowing them to informally determine the best way to write their algorithms and to plan the layout of the project. Using pseudocode is an efficient way to manage and document your coding operations or decisions or the processes. What are the main constructs of pseudocode? To properly represent an algorithm, pseudocode includes representations of several elements of programming logic, also known as constructs. These constructs are the structure that explain the various, components, such as the sequencing, and we'll talk a little bit more about that. You always write pseudocode constructs in uppercase as an easy way to tell a reader that the phrase describes a critical action for the algorithm. The primary constructs you use in pseudocode are sequence. A sequence is the order of tasks in an algorithm. In pseudocode, items in a sequence are each on their own line, one after the other. All tasks are linear, so each task occurs in order and no task happens at the same time. Okay? There's also the if then else. In pseudocode, if then else is a construct that describes part of an algorithm with two possible outcomes. It's a conditional statement that involves explaining what happens if one event occurs, then explaining what happens if that event does not occur. So, if then else commands are a type of sequence because you can first consider the condition, then choose a single outcome. So let's say an example would be if the user age is over 21, then display a welcome message. Else, display a denied message. So it has like this if else statement within it. Now, case is the construct for the conditional statements with multiple outcomes. It comes from the phrase in the case of. While you use if then else for algorithm statements with two possibilities, case is for statements with two or more statements. You use the pseudocode to explain what happens when each possibility happens. For example, case number of posts. Under 100, display novice icon. 100 to 1000, display intermediate icon. And over 1000, display expert icon. So that would be multiple steps, not just two. And so you use the case to define that. For. Let's look at the for construct. For is a command that shows a repeating action, also known as a loop. You use the for construct when you want to apply instructions in an algorithm to every item in a data set. Again, every item in a data set, right? To use this action, you define the boundaries of the data you set you want to use, and such as a list of the numbers. Then you describe the action you want to apply to each of those numbers. It's critical to know that the action will be applied to each of those numbers. So, for example, say for each day in a month, calculate the number of active daily users. So that way you would be actually every um, day of the month you would be doing that. So it's an action applied to every day of the month in that for loop, right? Repeat until. So the repeat until construct is a type of loop that continues until a certain situation happens. It's similar to for, but instead of applying actions to a particular data set, it loops the action until the algorithm achieves a goal. You list the sequence you want to repeat first, then explain when you want the sequence to end. So it has sort of that until part. Until that is implemented, you can then you can have the sequence end at that with that condition. So, for example, repeat email new customers until 1,000 replies. So after 1,000 replies, it will stop. So there is also the while, and there are several other constructs, right? While is sort of like this. While is another looping element that explains the limits of the loop at the beginning of the statement. While repeat until is a loop that lists the condition of the loop at the bottom of the code, while is a loop that describes the condition at the top of the code. So when using the while command, the loop only happens if the condition you provided is true. If the condition is false, the loop will not happen. So while the number of daily active users is under 100, send weekly reminder email. So if it is above 100, you do not have to send weekly reminder emails. Although these six constructs are the most popular elements of pseudocode, there are many other keywords you can use in your work. Because pseudocode is informal and meant for human beings' interpretation, you get to decide which words to use to represent your algorithm. But know very well it is a communication methodology. So if you are using unique or custom keywords to represent specific actions other than the six main constructs, consider creating a glossary to explain each one so that a person who might be in the other corner of the world should also be able to understand the pseudocode as you're collaborating with them. Let's look at a few advantages and disadvantages of pseudocode. There are several benefits of using pseudocode on a programming project. Brainstorming, the process of writing pseudocode, can help you think through the logic of an algorithm and solve problems before spending time and resources writing the technical code. Collaboration. Pseudocode uses simple language which makes it useful tool for explaining complex technical details to stakeholders and other collaborators who may not understand programming languages. Efficient instruction. Once you complete your pseudocode, you can use it as a clear outline for translating each line into a programming language. And last but not the least, definitely very, very important, is documentation. Saving your pseudocode documents can help you record project goals, best practices, and ideal outcomes for project, which can help you make corrections and updates to code in the future. Right? So, what are the disadvantages of pseudocode? Well, working with pseudocode involves some challenges to consider, right? If you want to use it, it isn't standardized. So, you have to make sure you have a glossary. So, each person may have their own preferences or style that they use for their pseudocode. Writing pseudocode also does take time and planning. You have to meet with everyone, you have to get on the same page, you have to make sure your algorithm flows, your process is communicated, and everyone sort of has a say in it in terms of how to debug and test and all of those features. This also means delaying the process of actually writing the code. Well, planning ahead and using efficient, consistent pseudocode practices is an important, very, very important strategy for overcoming these challenges and making them more efficient while enjoying the full benefits of pseudocode. So here are a few practices, best practices for writing pseudocode. Um, Definitely capitalize the construct keyword. Only use one construct per line unless it's paired construct like if then. When using multiple construct, use indents to organize the code. This helps with the readability of the code. Use plain language that describes the problem you want to address. And when combining multiple elements of pseudocode, use the phrase end plus the construct keyword to show that an element of pseudocode is complete. For example, end for or end while. Right? There are few, these are just a few best practices for writing pseudocode you can use to improve, sort of your function and readability and communication, collaboration across your team. You, as a team or individual, can develop your own pseudocode writing style while still following some of these basic guidelines. So it's sort of an and discussion where you can add on to this as you iterate through your programming process or your pseudocode. Um, just the main goal is to make it easy for others to interpret your code instructions, and to, of course, collaborate on the algorithm. Let's look at how to write the pseudocode, right? So the exact process you use to write pseudocode varies depending on the process of your algorithm, but it involves the same basic steps. Here is a quick overview of the four basic steps that might help you. Again, this is just a quick suggestion. You always add and subtract steps to this as you sort of go through your process. So create a flowchart. Start by developing a flowchart of the main functions you want to complete with your algorithm or programs. The flowchart can be very basic, including only a few functions with arrows indicating the direction of ideas. By starting with a flowchart, you create a visual representation of your code, reference your flowchart for inspiration and inference about what constructs to use to complete each action. Write down an action. Set limits. So let's talk about writing down an action. Start by writing down one action of your code to complete. For example, displaying text on a website, calculating an equation, or printing a document are all actions you can initiate with code. Always begin with the first action in a sequence to keep your pseudocode organized. Set limits. Use constructs to set limits for the first action in your flowchart. Decide what types of sequence, loop, or conditions you need to make your code work. For example, if you want your algorithm to print certain documents, use the for construct to explain which pages to print. Combine constructs. Modify and combine constructs to create custom pseudocode that describes complex operations. Remember to use indents or another form of spacing to organize groups of constructs, especially when nesting one construct within another. For example, if you start with an if then else construct that tells the algorithm to print tests for fourth grade students on blue paper and tests for fifth grade students on green paper, you can then add a repeat until construct that instructs the program to keep printing until you have 100 total tests. So here is a quick pseudocode example, right? Here's one example of pseudocode for an algorithm that generates paychecks to illustrate how it works. A flow diagram, often referred to as flowchart, is just one way of representing a sequence of steps in an algorithm. Here we can see that we start at the loop, we input a number from the keyboard, right? Um, just a second. Uh, let's actually first talk about the example of pseudocode for an algorithm that generates a paycheck to illustrate how it works. So you have this while loop where you have greater than 50 employees is greater than 50, auto generate paychecks. So display the employee name, hours worked, paid time off, yearly salary, display hourly rate, and then you have the end for. So you see that you have a for loop, you have an end for hourly employees, multiple hourly rate by hours worked, and then you end for all employees, subtract withholdings, and for. And as you go down the code, you will see a specific way of implementing the conditionals that we have talked about, including the while, the if else, the for, the case, and the repeat until. So you have a really nice example where we are implementing all of the constructs that we talked about before. So right now, let's look at an example, a simple example of writing an algorithm to output the largest of the two numbers entered by the user. So here is, we can see that we start, there is a flow chart, which is nothing more than one method of representing the sequence of steps in the algorithm. And here we can see at the top, we input a number from the keyboard. We input a second number from the keyboard. We ask, is the number one greater than number two? And if it is, then we follow one branch. If it is not, then we follow another branch. And there's different outputs depending on the outcome of that decision before the program comes to a stop, right? So there are different outputs, and then the program comes to a stop. Now, pseudocode is like a halfway between English language and actual programming code in a programming language. It looks a little bit like a programming language, but doesn't follow any specific syntax for one given language, right? So it wouldn't be in Python or JavaScript, as they have different syntaxes. So instead, it's more generic code that could easily be applied into any programming language that a programmer wants to use. So in this example, we are inputting our two numbers. So you see that number one, number two. And we are saying if number one is greater than number two, then print the largest number, that is number one. Otherwise, print the largest number is number two and then end, right? So we are printing, if number one is greater than number two, then print number one, else print the largest number is number two, and end, right? And you see that endif is included, just like our best practices as we mentioned before in pseudocode. Sometimes we are creating an algorithm from scratch. Other times you might be presented with one already in the form of a flowchart or pseudocode, etc. And then you will be asked to refine that algorithm or to add more to it or make it more efficient. So So here we see our previous flowchart from an algorithm to output the largest of the two numbers entered by the user. And we are being asked to refine it. So we will now output the largest of the three numbers entered by the user. You would first need to identify the areas of the existing algorithm which needs modifying. So well, we would clearly need to modify this top section, which is right here, the input number one and input number two. To take in an extra input from the user, which you can see we've done here, right? We would also need to modify this bottom section, which is this particular one. And now this will require a little bit more thought. So why don't you sort of take a look at it, give it a few minutes. You can also pause the video and see how you would structure this in terms of the refinement. So you have to change this so it can take the input. You might have to change the logic. And then what would this block look like as well? Okay. So this might be a good time to pause. I'm going to move on right now so that you can see what we are talking about. We would clearly need to modify this top section to take an extra input from the user, and you can see we've done here, right? And we would also, so we've added an extra input, and we would also need to modify this bottom section. Now, this will require a little bit more thought, so we'll talk about it in just a minute. Um, you still got the number 1 greater than number 2. But then if the answer is yes or no, we are performing another check. And depending on the result of that, we are either outputting number 1, 2, or 3 in the largest. Of course, in the exam or in any sort of algorithmic discussion, you may present it with this algorithm in different form, and you could be asked to present your answer in pseudocode of your preference, or of either the sort of the reference language that they give you, or high level program code of your choice, right? So here's another example of the flow diagram. Now this diagram calculates how much, um, how we are going to modify this, and then we have the refined algorithm where the number, we modified this from here, right? So it is number 1 greater than number 2, then is number 1 greater than number 3. So you have another decision tree. Then it goes on to outputting the number, the largest number, and then stopping. So you have a much modified, refined algorithm which addresses the question of how to write an algorithm to output the largest of 3 numbers entered by the user. Right? This is the pseudocode for the program, and you can see right here we have the 3 inputs. We have the if, and if, else, and then we are printing the largest number is either number 3, number 2, number 1, depending on the condition. Here is another example of a flow diagram. Now, this algorithm calculates how much carbon to dose into the fish tank to keep nitrates at bay. It starts by asking what the nitrate level is and says if the nitrate is above, or nitrate level is above 10, the output then output 3 ml. If not, it nitrates above 2.5, and if they are, then output 2 ml. And if they're not, if the nitrate level above 1, and if it is, then dose 1 ml. So it sort of goes through this iterative decision 3 ml. If it's 2.5, is the nitrate above 1, and then dose 0.5 ml, or output dose 1 ml, right? We can, of course, express this algorithm in pseudocode. Here's a comment just to explain the purpose of the program next, right? We've got a variable called nitrate, as you can see right here, which is entered from the keyboard. We ask if nitrate is greater than 10, then dose 3 ml. Otherwise, if the nitrate is greater than 2.5, then dose 2 ml. Otherwise, if nitrate is greater than 1 dose, 1 ml. Otherwise, dose half an ml, as it's stated here, like print 0.5 ml. It's exactly the same program, just expressed in a different way in English language, right? That's your pseudocode. So all flow diagrams use a common set of symbols. There are many symbols, but 6 of the most popular ones that you're expected to know for the exams essentially are shown here. You always have the terminal symbol and the diamond symbol, which helps in your decision making or representing your decision making. You also have a process symbol which is the rectangle, and then you have a decision symbol, as I talked about before. It and it will always have this yes, or no, or true or false kind of statement. You also have a shape that represents a subroutine, right? And then you can write a separate subroutine. To a subroutine will have its own flowchart, but when you call it from the main program, you need to express that using the symbol, right? Finally, you have a line and the purpose of the line with an arrow representing the control passing between the connected shapes, which is your flow line. Let's look at this. This is sort of the reference language for writing pseudocode. And many a times you might get reference language like this or like this, which is provided to you by, say, the application creator, or you might have these for exams, for digital literacy computer science exam in Massachusetts, provides reference language like this. but you would then use the existing reference language to address questions. And this is and you will notice that it looks a little bit like Python because it is deliberate because we know most of the schools and people are using Python to teach programming. So it's in a way, it's bringing you very close to what the actual programming language is, right? Um, so let's quickly look at it. Comments are denoted by double slash. Inputs use the input command, and variables can either be a number or strings, which are identified in double quotes. The global command identifies a variable, can be used in any subroutine or function instead of being declared inside the subroutine or function, which would make it only available to that particular subroutine or function. The keyword constant defines a constant. There are values that don't change throughout the life of the program. And Python actually doesn't support constants. So you would have to initialize a variable and then never change its value while the program is running to get the same kind of functionality. There's also casting and logic operators and many more constructs that you can go through, right? We also talked about the if else and the case select. Um, it's an alternative to multiple else if is to use a case select or a switch statement where you say switch x and then have various case statements which can match. So there are different ways of utilizing this reference language in writing your pseudocode. Here is a quick um, breakdown of similarities and differences between algorithm flowchart and pseudocode. We will be including this into your readings as well, but just sort of a quick summary of what some of the key definitions and key processes are with all three of these. There's another picture representation of it. um, just want to make sure that you are um, you know you are familiar with pseudocode. You sort of go through these examples and understand the benefits of writing a pseudocode, right? So when you're writing code in a programming language, you will work with a strict syntax and write coding patterns. But when you write pseudocode language, it is rather um, lucid, and it allows you to create something that it can be written in English and can be understood by many, if not all, right? You do not have to obey the set of rules. You can also make the rules yourself if or make up certain words. However, you have to make sure you communicate that glossary to your team or people you're collaborating with and to the audience. Pseudocode acts as a bridge between, think of it as between humans and computers in your brain, and sort of allows you to visualize that process. And you can really get very good, high quality code from many different platforms if you actually put in the time to create a, a, a collaborative process wherein you are contributing to that pseudocode and iterating together so that you arrive at a very efficient process that then you want to code. Um, Last but not the least, planning computer algorithms with pseudocode makes you meticulous, precise, and purposeful about your process and algorithm in general. It helps you explain exactly what each line in a software program should do. It's a great positive step and possible because you are essentially in full control of as you are developing this algorithm with your collaborator team, and you don't have to abide by the strict syntactic rule in the pseudocoding process. Um, thank you so much. In this learning session, it is similar to all other past sessions. We always urge you to broadly explore ways in which computer science connects with the real world, help solve problems, as well as enrich your teaching and understanding of computational thinking and computer science concepts, processes, and frameworks. This is not a narrow field. Everyone does not have to become a programmer. but these are processes which help us in our daily life in sort of simplifying the way we are doing things and articulating the processes and communicating those processes with each other. Through You have multiple readings and articles that are referenced in this video as well as linked in the video, that could further your understanding of this learning process of pseudocode. Hope this was helpful to you. Thank you again. This is my information. You can always contact me. Have a wonderful, wonderful day and happy learning, computational thinkers.